So we get a bunch more formulas now. Okay, multiple angle and product sum. You know, by far the one that we do the most out of this section is double angles. These are the double angle formulas. And the thing is that you can derive these formulas by using the sum and difference, or the sum formulas. Like if I use the sum formula, remember the sum formula looks like this. Sine of u plus v equals sine u cosine v minus cosine u sine v. Okay, but we don't have u and v. We actually have u plus u. Right? 2u means this is the sine of u plus u. So we get sine u cosine u. That's a plus, sorry. Plus cosine u sine u, which is 2 sine u cosine u. So if you just do the sum formula, but the angle is the same angle, then it simplifies to that. 2 sine u cosine u. And same thing with the cosine of 2u, right? This is the cosine of u plus u, which if I put that in the formula, it's going to definitely give me this cosine u minus sine u, which is cosine squared minus sine squared. All of these here they've been substituted to make them purely one or the other, sines or cosines, right? So what do you substitute to turn this cosine squared minus sine squared into something that doesn't have sine squared in it anymore? How do you go from here to here? Well, you're going to say 1 minus cosine squared is sine squared from the Pythagorean. And by doing that, you turned it into all cosine. Now it's 2 cosine squared minus 1. If instead you substitute 1 minus sine squared for the cosine squared, you get that. So there's actually 3 different formulas there. And you're going to use the one that suits you almost all the time. It's going to be one of either the second or the third. I mean, there's not much call to substitute with both the sine squareds and the cosine squareds. You probably want to get it to just one. But that's how you make them. Just use the sum formulas, but you're using the same angle. So it simplifies. And then the tangent, again, if we substituted, the tangent formula is this. Tan of u plus v equals tan u plus tan v divided by 1 minus tan u tan v. Okay, but if it's u and u, then that's 2 times the tangent of u, right? And if this is tangent of u times the tangent of u, then that's a tangent squared of u. So it all makes sense if you know the sum formulas. You don't even need the difference, right? You just need the sum formula. So this gives us a way to, if we have a double angle, we can actually turn it into a single angle using these formulas. So solve. So if you're looking at, this equation right here, one term is a cosine of 2x, another one is cosine of x, and you need it to all be the same thing. So that's why we would use a double angle formula to convert this cosine of 2x to a cosine or a something of 1x, right? We need it all to be an angle of x. Okay, how would we do that? Well, I'll go back to this page. If we're going to substitute for the cosine of 2x, then we've got to take our pick between these here. Right? Which one are we likely to choose when there's also a cosine of x in that equation? You're probably going to want to use this one here. So you leave it all in terms of cosines. And then, it'll probably be a quadratic type. You'll have to solve it like a quadratic type. So we're going to substitute for the cosine of 2u, 2 cosine squared u minus 1. That's this one right there. 2 cosine squared u minus 1 plus cosine x equals 0. And I can rewrite that 2 cosine squared, I should make that x, sorry. X plus cosine x minus 1 equals 0. And that's quadratic type. You'd have to factor it. I think we've done this exact problem before. Once we get to that point, I think it was 2 cosine x has to be the first term and cosine x in the other. And then it's going to be some combination of plus 1 and minus 1. And you can play around with it, but that's going to have to be the plus and that's going to have to be the minus, so that the middle term is plus cosine x. Okay, now zero product property. Cosine x equals 1/2. Cosine x equals -1. Where does cosine x equal 1/2? Pi over 3 and 5 pi over 3, right? But now this one, it didn't say only between 0 and 2 pi, so we've got to include that x equals pi over 3 plus, and what is the thing you write after that? 2n pi, right? Multiples of 2 pi, adding and subtracting multiples of 2 pi gets you back to the same place, coterminal angle, so that would be it. And then we'd also have to have x equals 5 pi over 3 plus 2n pi. How about the cosine x equals -1? Cosine x equals -1 there. So what's the angle? Pi. So x equals pi plus 2n pi. Is it good? Okay, this is similar to the last question in the homework where they're going to tell us the value of the sine and the quadrant that we're in. And then we're supposed to find sine, cosine, and tangent of 2 times the angle. So let's see. First, let's draw our triangle. Right? If it's between 0 and pi over 2, then it's first quadrant. Right, and the angle is theta. The sine is 3/5, which means that side is a 4. And so if we're going to do these, now we just need to use the formulas. Right, this will be the sine of 2 theta equals 2 sine theta cosine theta, which is 2 times. What is the sine of theta? 3/5. What is the cosine of theta? 4/5. So what does that equal? 2 times 3 times 4. 24 over 25. Okay, cosine. And again, you got 3 choices. Whichever formula you want, it's going to get the same answer, whether you think one of them is easier than the other. If you go back to that, I mean, it doesn't really make much difference because now we don't have a problem having to substitute for cosine and sine. That's not hard. If we just substitute for cosine, then we're going to have to find a common denominator in order to add those 2 together. Same thing this one. That's why it's almost easier to just do that one because you won't have any issues with finding denominators. Not that it's hard, but I'm just going to use the cosine squared minus sine squared. cosine squared theta minus sine squared theta. And the cosine squared is 4/5 squared minus the sine squared, which is 3/5 squared, which is 16 over 25 minus 9 over 25, which is 7 over 25. And this is 5, 5, 5. I wonder if I did that. Sorry. 5. Where's my clipboard? And then the tangent, I mean, you have a formula for that, but if you've already done the sine and the cosine, how else can you find the tangent of 2 theta? You're going to divide the sine of 2 theta by the cosine of 2 theta. So they'll divide 24 over 25 by 7 over 25, which will be 24 divided by 7. Right? If I plug in the formula, it'll look like this. Tan 2 theta equals 2 tan theta divided by 1 minus tan squared. Right? The tangent of theta is 3/4. Right? So that's 2 times 3/4. 1 minus 3/4 squared. So this is 6/4 divided by 1 minus 9/16. Okay, which is 16 over 16 is going to give us 7/16. Right? 6/4 over 7/16. And if I flip and multiply, I hope this works out. Then I get 4 goes into 16. It's 4 times 24 over 7. Which is what we would have gotten if you just divided this by this. So double angles. Now, when it says double angles, and this is kind of an important concept here, is it's not just that you would be able to convert the sine of 2 theta to something that involves sines and cosines of 1 theta. You could take the sine of 4 theta, and that would be equal to the 2 sine 2 theta cosine 2 theta. It's as long these are double. That's the point, right? 2 times 2 theta, 4 theta. So the formula works. Same thing over here. This cosine of 6 theta would give you, you'd express that in terms of cosine squared 3 theta, sine squared 3 theta. So it doesn't just limit you to dealing with exact double angle, right? 2 times an angle. You could use it for 4 times an angle and 6 times an angle, 8 times an angle, whatever it is. It just this angle is double that angle. And then you just move it. And we'll use that in a minute. So in fact, this section right here, what they talk about is not just double angles, but it's sine of kx, meaning that it could be some other constant, like the last slide, 4x, 6x, can be anything like that. Here they just show how you could use, you could find this, a formula for the sine of 3x. First use the sum formula, right? Make that a 2x plus x, and then you'll use the sine of a sum. Sine cosine plus cosine sine, right? Sine of 2x plus cosine x. Cosine of 2x times sine x. And because we need this all to be in terms of x, not 2x, then we substitute for the sine of 2x using the formula. 2 sine x cosine x. And we substitute for cosine 2x using the formula. And since they said make it in terms of sine x, they're using that version right? So 1 minus 2 sine squared. Now, as you simplify from this line to this line, you still have a cosine squared. So what are you going to substitute to get rid of the cosine squared? The 1 minus sine squared, right? So once you do that, it all simplifies to this. Now you have an expression for the sine of 3x, which does not involve any multiple angles. It's just sine of 1x. Now, why do you do some of this stuff? There are some of these that I definitely know that we do, because when you get to calculus, you can't handle that, but you can handle that. But I can't say all of them are like that. I can't say some of these are just not exercises and, you know, seeing if we can do it. But some of them are definitely things that I can see. I mean, the main thing you do in calculus, you do derivatives and you do integrals. And sometimes it's, especially with the integrals, the form that you're trying to take the integral of makes a big difference to whether you can do it. Okay, now these are called power reducing formulas. And, you know, why are they power reducing? Because on the left, all of these are squareds. And on the right, they're not. So you're going from something that's squared, has a power, right, to something that doesn't. Now, these are just rearranging the double angle formulas that we've already got, specifically the cosine of 2 theta. And you can see this if you do this. Just if I multiply the 2 onto this side, right, I'm going to get 2 sine squared u equals 1 minus cosine of 2u. And then if I solve for the cosine of 2u, right, it's going to be cosine of 2u equals 1 minus 2 sine squared. So this is just a rearrangement of the double angle formula for cosine. And this is the same thing, right? If I multiply the 2 up here and then subtract 1, I'm going to get 2 cosine squared u minus 1 equals the cosine of 2u. So I guess if you wanted to reduce the power of something, then you would go to one of these formulas. You know, I just say, you guys are going to get the formulas, right? I'm going to give you the formulas. You have to know how to use them, right? When I went through this stuff, we didn't get the formulas. And we tended to, like, you would memorize the least amount of stuff possible. You definitely had to have the sum and difference formulas memorized. And then from there, you should be able to figure out the double angle formulas, right? Just like we did on the last slide. And then from there, you could figure these out just by rearranging it. I mean, all of those things came pretty easily. How do you think they get the tan squared? You know, how do they reduce the power there? Yeah, just if you divide this by this, you know, the divide by 2's cancel, and you're just left with that. So there's your formulas. So this is a little bit of a drill, but rewrite the tan fourth to the x in terms of the first powers of cosines. So how can we use, I mean, which one of these are we going to have to use? For sure. It's the tan squared, right? You're going to have to use this one right here. But we don't have tan squared. We got tan to the 4th. So how are we going to deal with that? Yeah, this is tan squared x times tan squared x. Okay, so we're going to substitute twice. Just remember, it's the 1 minus in the numerator. So this is 1 minus the cosine of 2u. I keep forgetting. 1 minus the cosine of 2u, but I need to not say u. I need to say x because it's x. So 1 minus the cosine of 2u, 2x, divided by 1 plus the cosine of 2x, 1 plus the cosine of 2x. Right, this is just doing it twice. And then you're going to simplify by foiling. Right, so when I FOIL these in the numerator, I'm going to get 1 minus 2 cosine, where's my x? Cosine of 2x, sorry, plus cosine squared of 2x, divided by 1 plus 2 cosine 2x plus cosine squared 2x. Right, just FOIL them both. And don't try to cancel terms. You cannot cancel these terms. Okay, very bad mistake. Okay, did we answer the question? Did we rewrite it in terms of first powers of the cosines? Not quite, because we've still got this cosine squared of 2x. So how are we going to deal with that? How do we reduce the cosine? 1 plus cosine 2u over 2. Right. So now we need to do that twice, once in the numerator, once in the denominator. So this will be 1 minus 2 cosine of 2x. Okay, then this last one is 1 plus the cosine of 2x. Oh, actually, let's see. Right, when you take a cosine squared and you put it into this formula, it's going to double that angle. So if that starts as a u, it ends up as a 2u. For us, right, we're starting with a cosine squared of 2x, so this has got to be 4x divided by 2. And now we've got to divide by, similar, 1 plus 2 cosine 2x. Plus 1 minus, no, it's the same substitution, 1 plus cosine of 4x divided by 2. Okay, now, is it all written in terms of first powers of cosines? Yeah, it is, but that's probably not a simplified form that we could live with, right? Remember, when you have fractions inside of fractions, that's called a complex fraction, and we probably shouldn't leave it like that. How could I get rid of the fractions within fractions? Multiply it by 2, right? Multiply the top and the bottom by 2, right? Whatever you do to the top, you got to do to the bottom. And when you do that, this is going to be, in the numerator, you're going to get 2 minus 4 cosine 2x. And then the 2's here cancel, and we're just get plus 1 plus cosine of 4x. And denominator will be 2 plus 4 cosine 2x plus 1 plus cosine of 4x. Okay, but now there's a little more simplifying you can do, which is about the 2 plus 1, combine like terms. So now we'll write it like 3, and the numerator will be minus 4 cosine 2x plus cosine of 4x divided by 3 plus 4. And then that's as simple as we can make it. Right? Remember, you cannot cancel anything in there. Nothing. I guarantee half the students are going to cancel something. It's just too tempting. You look at that and say, oh man, look at that. When do we get out of here? 35? Okay. Thank goodness for that extra 5 minutes. Okay. So then you got half angle formulas. So you could see what is it that makes it a half angle formula? You know, you've got the u over 2 here and the u inside. So this angle is half the angle of that angle. That's it. Now, if you square both sides, let's just take the sign just to show it with the sign. Right? If I square both sides here, it needs to be around the plus or minus, then it would look like this. Sine squared u over 2 equals, now when you square the plus or minus, no more plus or minus, then you've got 1 minus cosine u divided by 2. Okay. So I am going to solve for the cosine of u. Okay. Multiply by 2. Two sine squared u over 2 equals 1 minus cosine of u. And then I'll subtract 1, multiply by negative 1, however you want to do it. This says the cosine of u equals 1 minus 2 sine squared of u. Sorry, of u over 2. But again, these formulas, the main thing is that this is double what that is. So if I just said, okay, instead of saying this is u and this is u over 2, if I'm saying that's u, then what would this be? If this was angle u, this would have to be twice the angle u. So it would be the cosine of 2u equals 1 minus 2 sine squared u. But that is our double angle formula for cosine, which again, all these things are rearrangements of the formulas we're already using. There's nothing new here at all. They're just rearranging stuff. You know, now the place where they use this kind of thing is like the next problem. Right? If it said, find the exact value of the sine of 105. Okay, well, if it says exact, that's supposed to be a unit circle value, right? Well, 105 is not a unit circle value. Okay, well, what about doubling it? If it was 2 times 105, it'd be 210. Is 210 a unit circle angle? Yeah, so you'd go like this. The sine of 105 equals, and then you use the formula, and then inside of the radical, it's going to be 210, which is something you can deal with. You can turn it into square root, unsimplified square roots, and it will be exact. Now notice they say, because there was a plus or minus on this, and you've got to pick which one to use, they said since 105, okay, 105 is in quadrant 2, sine is positive there. So you would definitely, use the plus instead of the minus. And this gives you a kind of an odd answer, right? If you look at this, because the cosine of 210 is root 3 over 2. Now you've got square roots inside of square roots, which doesn't happen very often. But if you're going to make it exact, that's what it would look like. So what did we started with the double angle formulas. Then we had the power reducing formulas, which are just a rearrangement. Then we had the half angle formulas, which are just a rearrangement again. And then we get these last ones, which are called product to sum and sum to product. So you can see why this one is called product to sum, because this is a product and these are all products, and these are sum or differences on this side. Now, this is not a rearrangement of those other formulas. It's not. However, you should be able to verify these. Use the sum and difference formulas. You know how to rewrite the cosine of u minus v and the cosine of u plus v. Then do it and see whether everything doesn't cancel, and you end up with sine u, sine v. I mean, you could just try it and see what you get. I mean, this would be a good verify problem for the test. verify one of the product to sum formulas using the sum and difference formulas. And those are the sum to product, right? Same thing. These are sums or differences, and these are products. And you should be able to verify those. So these, notice that these have well, that's u plus v over 2. You'd have to do u over 2 plus v over 2 and do the sign of a sum. U over 2 minus v over 2, the cosine of a difference. And see what kind of cancellation, and then somehow these u over 2s are going to have to turn into a u, and the v, the v over 2s are going to have to turn into a v. So there's going to be somewhere in there the double angle formula's got to show up. Wait, Jimmy? Yeah. And that's it. Honestly, I mean, I don't do much with this stuff. I'm not going to, there were examples that you were doing more with that, but I'm not that interested. Some of this stuff just gets so far into the weeds that the reality is we're probably not going to have much of those kinds of problems. Like the most I could see is that I think it's a fair question to verify one of those. If you've got the sum and difference formulas right in front of you, you should be able to see if you can simplify it. And there's a lot less homework here. Mostly it's focused on the sum and difference formulas. There is a couple at the end which are using the half angle formulas just to find an exact value, but that shouldn't be too tough.